Hey CW Apes, Mr. Kennedy here, and this is part 2 of your lecture from Chapter 10 on environmental hazards and human health. So in this installment, we're going to take a look at toxicology and some of the chemicals that we might consider to be toxic. All right, so toxicology is the study of poisons and their effect on living systems, right? So if you're studying, how, lead affects human beings, that's toxicology. If you're studying how mercury affects plant communities, that's toxicology. Toxicology is not just an area of science focused only on people. It's focused on poisons and their impact on any living system. Dangerous chemicals are actually divided up into two broad categories. Those categories are toxic or hazardous. In order for you to be toxic, well, that poison or chemical would have to damage or kill cells and tissues. And these could be very, very specific. Like maybe they just attack like your thyroid gland or your liver. Okay. Um, so when we think about toxic, these things are often harmful even at really, really low concentrations, which is what it means there on the slide when it says dilute concentrations. Like you don't need much to do a lot of damage. Other chemicals are considered hazardous. They're dangerous, but not toxic. They can be flammable, explosive. They can just irritate your skin, your eyes, your nose, your lungs. They could be an acid or a base that might burn you, but unless you were showering in it, it's not necessarily going to kill you. Exotoxicology or ecotoxicology deals with the interactions, the transformation, the fate, and the effects of natural and synthetic chemicals in the biosphere. So when these poisons get out in the environment, eco toxicology, like that's the area of science that's going to look at what's going to happen to these things. So let's work through some specific toxins, okay? Now, when you think toxins, my brain automatically goes to, the worst of the worst, things like lead and mercury. But believe me when I tell you that there are toxins that aren't the worst of the worst that a lot of people take for granted, like these simple allergens. An allergen is considered a toxin. Okay, any substance that can activate your immune system is an allergen, and it could be considered toxic because it moves you away from, mental, physical, like social well-being, and it could damage or kill cells and tissues. Now, as it triggers your immune system's response to an allergen is often to produce antibodies that, well, get rid of the allergen's antigens. Antigens are substances that are recognized by your body as foreign invaders, and it's up to your white blood cells to stimulate the production of antibodies to render those antigens, well, harmless. Other allergens can act indirectly by binding to other materials so that they become antigenic. For example, formaldehyde and carbon monoxide, that's what causes sick building syndrome. People who are in like new construction or maybe even an old building, really doesn't matter the age of the building. Well, if you get the combination of carbon monoxide from, leaking pipes from a radiator and formaldehyde, you could end up with people getting migraine headaches, being nauseous, being very, very sick just from being in the building. That's why it's called sick building syndrome. Immune system depressants can also be considered toxins. These are pollutants that depress your immune system. There are endocrine disruptors that are toxins. Endocrine disruptors disrupt normal hormone functions. There are environmental estrogens to take into consideration here. Environmental contaminants such as BPA and dioxin cause reproductive problems in animals, even at very, very low doses. We get exposed to BPA through plastics and other types of like Tupperware and things like that, water bottles. That's where we get BPA from. There are neurotoxins for us to consider when we think about toxins. Toxins that are, well, metabolic poisons that attack our nerve cells. These, well, they're usually extremely toxic and fast acting and include heavy metals, which kill our nerve cells, anesthetics, chlorinated hydrocarbons, which disrupt our nerve cell membranes, and organophosphates and carbamates, which inhibit the signal transmission between nerves. Then we have mutagens. Mutagens are agents that damage or alter our genetic material. They can lead to birth defects or tumors. Teratogens, like these specifically cause abnormalities during embryonic growth and development. Alcohol is a great case in point, but not the only one that I'm going to share with you here. Carcinogens, their name says it all. Substances that cause cancer. Cancer is the second leading cause of death in the United States. Do you remember what the first one was? Yeah, it's heart disease. 1 in 2 males and 1 in 3 females in the United States will have cancer in their lifetime. Now, some other things that we need to consider. One last item that I want to add to the list, diet. There's a huge correlation between high fat, high salt diets and cardiovascular diseases, which can lead to illness, deviations from that overall physical, mental, and social well-being. Having diets high in fruits, vegetables, whole grain, complex carbs, fiber, they're not just beneficial for your overall weight, but they can help your body deal with all those other toxins that I just mentioned, right? So it's really, really important to have proper diet to increase your overall health. Now, I'm going to give you some examples of those toxins that I just threw at you by definition on those previous slides. Here we go. So our toxic chemicals, remember, to be toxic, you have to be fatal to over 50% of the test subjects at given concentrations. Here's a list: dioxin, mercury, cyanide, benzene, chloroform. All of these can kill or impair, an individual. Okay. Hazardous. Remember, these are not necessarily toxic, but they could be dangerous, explosive, corrosive. The list of a few items of examples are in this picture: antifreeze, paint, household cleaners, paint thinner, gasoline. Those are all hazardous chemicals, but not something that is considered toxic. Mutagens. Remember, a mutagen, well, it changes our DNA. Chemicals or radiation that cause mutation. I've got a crazy list here of a bunch of stuff that actually are mutagens. I don't want you to learn the entire list. I want you to focus on things like benzene in that list. Benzene is something that's been used as an industrial cleaner for years. It is a mutagenic agent. Carcinogens, they cause cancer. We've already said that. But, like, what is cancer? And, like, what are some things that could cause cancer? Well, radiation, viruses, or chemicals that we get exposed to that lead to uncontrolled mitotic division. Like, that's what cancer is all about. Cancer cells basically cannot regulate their growth. They divide out of control, and they can break off from the tumors that they form and spread throughout the body and start doing that uncontrolled cell growth in other places. That's called metastasize, where they break off from tumors and travel to other places. Now, where can we get carcinogens? Here's a great one, okay? Cigarettes. Cigarettes are loaded with carcinogens, right? These carcinogens go directly into our lungs and can lead to lung cancer. Now, just because you smoke a cigarette, that's not a guarantee that every person that ever smoked a cigarette every one of them's going to get cancer, but you're increasing your odds by smoking, right? Look at the list of other things that are included in cigarette smoke, right? There's acetone, which is a solvent, right? Naphthalene, which basically is like the preservative for mothballs, okay? There's methanol, which is an additive for rocket fuel. So nicotine, which is the addictive part of cigarette smoke. Arsenic, which is a toxic poison. DDT, which is an insecticide. There's carbon monoxide in the smoke. There's even vinyl chloride, which is used to make plastic. I mean, let's just be real for a minute. It's not good stuff. There's a variety of other carcinogens that I could go on and on and on about, but rather than do that, I'm going to leave you with this idea of cancer this way. It is the second highest cause of death in the United States. The rates of cancer survival are actually increasing. We are getting better at curing cancer. So that's a huge plus. Right underneath that, I've got the CDC table of disease control and prevention showing the number of deaths for leading causes of death in the United States. Heart disease is still number one, cancer's number two, and then it goes on from there with lower respiratory infections, stroke, accidental death, Alzheimer's, diabetes, influenza, pneumonia, etc., etc., etc. All right, teratogens. A teratogen is a chemical, radiation, or virus that causes birth defects during pregnancy. A great example of a teratogen is alcohol, which causes fetal alcohol syndrome. You heard me mention that in a previous slide. This is what fetal alcohol syndrome looks like. We got these pictures of these young people on this slide. It leads to mental defects, developmental delays, and even behavior problems as the alcohol affects the nervous system's development in the unborn child. Another example of a teratogen is thalidomide. In the 1960s, thalidomide was prescribed as a sleeping pill in Europe. Well, they didn't do enough background research or maybe didn't realize the teratogenic effects of thalidomide, and unfortunately, it caused abnormal fetal development in about 12,000 babies that were born. Those babies were born without limbs, no arms, no legs, right, as a result of the exposure to thalidomide. Ionizing radiation. Ionizing radiation is another, well, mutagenic agent that can lead to things like cancer and, have toxic effects on the body. The radiation causes atoms to become ionized. It impairs the function of tissue and organs. It can produce acute effects like skin redness, hair loss, and radiation burns, or it can cause chronic effects like cancer. Neurotoxins attack your nervous system. You got chlorinated hydrocarbons, DDT, lead, mercury, and organophosphates like malathion that all fit into this group, okay? The reason I have this little baby like picking at the paint at the bottom of the window is because back in the old days, lead was an additive to paint to stabilize it and enhance its color. And there was a time where, well, as this paint aged, it would become flaky, and I don't know why kids would eat it, okay? Not recommended, right? Paints of today don't have lead in them. They're all latex based, so we don't have to worry about that. Neurotoxins are also produced by things like black widow spiders. This is an example of Long Beach, New York, July 8th, 1945, where we're trying to get rid of things like mosquitoes by spraying these toxins like up and down the beach to protect people. Well, what we didn't realize was that those same toxins that we're using to kill the mosquitoes are neurotoxins for people. This particular toxin that's being sprayed is DDT. DDT is a toxin that, well, for a long time was considered the magic bullet in the fight against malaria and that type of infectious disease. Unfortunately, the mosquitoes that carry malaria became resistant to DDT and now drink it like Kool-Aid. So we can spray all the DDT we want, and they don't care. So that's a problem. Second, we realize that DDT is carcinogenic and a neurotoxin to people. So we can't just bathe beachgoers with DDT anymore. And third, we learned that DDT does not break down in the environment. That's a bummer. So, most things when you spray it in the environment, like if you take ant spray from that little can of Raid underneath your kitchen cupboard and you spray for ants, after about 2 or 3 days, that stuff's going to wash away and no longer be effective. Not so for DDT. DDT, once released into the environment, can stay potent and toxic and literally move its way up the food chain for years. That's where we get terms like bioaccumulation and biomagnification. So in bioaccumulation, individuals in an ecosystem will accumulate a toxin like DDT over the course of their lifetime. The longer they live, the more they accumulate. It could potentially lead to illness and disease if they hit that threshold point and, absorb enough of that toxin to kill them. Bioaccumulation is all about what's going on within the individual. Biomagnification is different. In biomagnification, the toxin moves up the food chain as individuals eat other individuals. So if I'm like this little brine shrimp and I absorb, I don't know, a pound of DDT in my body, that's never going to happen because brine shrimp don't weigh a pound. But I'm just saying as an example, okay? It might take my whole life to absorb that 1 pound of toxin, okay? Well, if a fish comes and eats me, rather than that fish living out its life to absorb maybe the same pound of toxin that I did as a little shrimp, it's going to get a mega dose of that toxin by eating me because I've already absorbed that toxin and living to the ripe old age in shrimp years of, I don't know, 5, okay? And now the fish gets a double dose. So it's absorbing the toxin from the environment that's in, and it gets a dose of toxin in almost pill form from me. And if a bird comes and eats that fish, I mean, it just marches right up the food chain. And what we end up losing more than anything else are our top predators in the food chain, like eagles. They start laying soft-shelled eggs. They can't reproduce. Without those predators, the whole food chain destabilizes. The food web collapses underneath it. All right. Next thing we're going to look at is heavy metal poisoning. Mercury is a fat-soluble metal. This is what caused Minamata disease. Minamata disease is also called Mad as a Hatter. Those of you that are fans of the movie Alice in Wonderland, you should know why the Mad Hatter is mad. And he's not mad because he's actually mad. He's mad because he's mad, like crazy mad, not angry mad, okay? Back in the olden days when they made hats, a lot of the dyes that they used to color the hats had mercury in them. So if you were a hatter, then you had your hands in these dyes, probably soaked up quite a bit of mercury, and it made you crazy, okay? So mercury can build up in your body tissues, in your fats, and it can lead to Mad Hatter disease, or basically it attacks your nervous system. It can also bioaccumulate and biomagnify the same way I just described DDT. So once mercury is out into the environment, right, individuals living in and around that mercury, they'll absorb it. And if those individuals are eaten, that mercury will move up the food chain. All right, hormone mimics and disruptors. Remember, these are chemicals that prevent hormones from basically doing their job because they get in there and they take their place. Dioxins, PCBs, plastics, pesticides, lead, mercury, and BPA are all good examples of hormone mimics and disruptors. Respiratory fibrotic agents. These are things that irritate, damage, and scar lung tissue. Probably some of the best known are coal dust and asbestos. Coal dust causes black lung disease. Now, unless you're a miner, not somebody under the age of 18, but like, the person that actually digs for coal, a miner. That was a joke. Just wanted to see if you're paying attention. Okay, so anyways, yeah, unless you're a miner, you don't really have to worry too much about coal dust exposure. But if you are digging for coal, this dust can get into your lungs and damage the lung tissue, literally turning it black, right? Black lung disease. Asbestos is a different story. Asbestos is everywhere. It can be in insulation. It can be in floor tiles and ceiling tiles. When those things are broken, the asbestos is like little shards of glass that float into the air and they get into your lungs, and at the end of the day can lead to cancer, right? So respiratory disease. So that's bad. These are respiratory fibrotic agents. Okay. Now, some of the last things that I want to hit before we take our break is that pretty much, when you look at a lot of these toxic chemicals, exposure to them is largely preventable. Like, again, smoking cigarettes, the nation's leading cause of preventable death, basically is cigarette smoking, right? 30% of cancers are actually caused by smoking, upwards of 1,300 deaths per day, and it's totally preventable. Same thing when you think about, a lot of the other stuff that I mentioned for you there. When you put yourself at risk, expose yourself to these things, like there's decisions that are being made there. And if you make a poor choice and expose yourself to risk, well, then you're going to increase your odds of disease and illness and vice versa. Okay. All right. That brings us to some biological hazards. Biological hazards are pathogens that are spread by air, water, food, body fluids, bacteria, viruses. There's even the case of parasitic worms. These are all things that are alive that could potentially make us sick. This is a list of the 7 most deadly infectious diseases according to your text. And at the top of the list is pneumonia and flu, which can basically be caused by bacteria and viruses. Okay. As we go down the list, we eventually finish with things like measles. Measles used to be much more high on the list, but because of vaccination, especially at an early age, measles incidences are decreasing. Okay. Now, how do these diseases get around? Well, this is an example of how malaria can be spread as mosquitoes bite people. They pick up the parasites and then they go bite somebody else. But we don't necessarily need a mosquito all the time to transmit the diseases for us. Sometimes all we have to do is be in close proximity with one another and, literally breathe, cough, sneeze, all that. And those diseases can spread from person to person quite easily. Okay. Um, from here, we're going to take a look at exposure and susceptibility. So when you think about exposure and susceptibility, the exposure part is pretty straightforward. When you're out there in it, you're exposed to it. Airborne toxins generally cause more ill health than any other type of exposure because you can't necessarily see them. They're all around you in the air. They're then easily absorbed into the tissues of the lungs. Food, water, skin contact, and other ways to be exposed to toxins. But like in those cases, you often have to have direct contact. You have to put your hands in it. You got to eat it, stuff like that. The largest toxin exposure reported is in industrial settings. So factories, things like that. The condition of the organism and timing of exposure also have strong influences on toxicity. Children are definitely more susceptible than adults when it comes to this idea of impact of toxicity. All right, ladies and gents. So the last thing Mr. Kennedy wants to share with you here are some chemical interactions and one chemical affecting another chemical, maybe making these things worse, and some health policy. So we're nearing the end. Hang in there. You're almost done. Now, chemicals can interact with other chemicals, and they can do so in a variety of ways. Chemicals can interact with other chemicals, maybe canceling each other out. That's what we call an antagonistic reaction. One material interferes with or affects the other in a negative way. Additive reactions occur where two chemicals, while occurring together, have an additive effect on one another. Okay. And sometimes that additive effect is like massive. And if that's the case, then we refer to that additive reaction as a synergistic reaction, where one substance literally just exacerbates the effect of the other. So here's a case in point. Asbestos exposure increases risk of lung cancer like 20 times. That's bad, right? But if you're exposed to asbestos and you're a smoker, right? Together, your risk of lung cancer jumps 400 times. Like that's a synergistic effect if I've ever heard one. Okay? So that's what we mean by synergism. All right. So your goal needs to be minimizing toxic effects. Like how do we protect ourselves and minimize the effects of all these toxins? Well, let's start like this. Every material can be poisonous under certain conditions, but most chemicals actually have a safe threshold under which their effects are insignificant. So as long as you know what that threshold level is and you minimize your exposure to them, you're taking the first step in minimizing toxic effects. Metabolic degradation is also important. In mammals, your liver is the primary source and site of detoxification for both natural and introduced poisons. Sometimes compounds that are harmless can be broken down into products that are actually harmful in some place like your liver, but more often than not, your liver can like process out a lot of the different things that you expose it to. If we're talking about mutation from ionizing radiation, stuff like that, um, if that's going to be much more difficult for us to get rid of, but there are still editing processes in your genetic material that can correct for that. We can even just excrete toxins, if they're water soluble. So the effects of waste products and environmental toxins can be reduced by eliminating via excretion, breath, and urine, and any irradiating agent can be potentially carcinogenic can be negated by the editing process in your cells. So that's all good stuff. Okay. To measure toxicity, remember sometimes we have to use animal testing. It is the most commonly used and widely accepted testing form. I know there are all kinds of humanitarian concerns using animals, and you may not agree with it. I'm not asking you to agree with medical animal testing. Different individuals have different sensitivities to the same toxins. So if it's toxic and like this animal over here, it may not be toxic, and that animal over there, and the same for people. Okay, there's all kinds of complications in measuring toxicity, so we just try to live by that LD50 measurement that I brought up in a previous video for you, where the lethal dose at which 50% of your animal test population dies sets the benchmark for our exposure. Unrelated species can also react very differently to the same toxin. So something that is maybe toxic to, I don't know, a cat, dog, fish, or frog might not bother a human at all. Okay. So these variations make it really, really difficult to estimate risk in people through animal testing. And obviously, we can't just test it on people because that would be even more unethical. So we create toxicity ranges to help us kind of gauge like how much protection we need when we're dealing with certain chemicals. Moderate toxin takes about 1 gram per kilogram of body weight to produce a lethal dose. A very toxic material would require about 10% of that amount. That's a smaller amount, not a bigger amount. Extremely toxic materials will only require 1% of that amount, right? So when you think about that botulism toxin we talked about a long time ago, like that's really, really toxic stuff because it only needs to be present in teeny tiny amounts to make you not just sick, but dead. Okay. So at the end of the day, like these toxicity ratios are super, super important to help us understand how much protection we need when we're exposed to these different things. All right, gang, you've been very tolerant and I appreciate it, but there is one last thing that we got to deal with down here at the bottom of all of this, and that is how your risk assessment has led to some risk acceptance. Well, when we think about risk acceptance versus risk assessment, the assessment is how dangerous is it? The acceptance is, well, am I going to listen to that dangerous or not, right? That dangerous measurement or not. So your risk acceptance is basically what people will tolerate. People will tolerate a high probability of occurrence if the harm caused is low. Okay. Great harm is accepted only at very low levels of frequency. For most people, if I were to tell you you have a 1 in 100,000 chance of dying, that might be a threshold for changing a behavior. If I told you your risk was 1 in 1 million, then people would be like, right? So, like it says here, the risk of dying of lung cancer if you smoke is 1 in 4, while the risk of drinking contaminated water with the limit of trichloroethylene is 1 in 10 million. So, you know, what are we going to focus on? Most people focus on the water, right? I don't know why, but that's what they do. Okay. Um, when you think about establishing health policy, well, it's really, really hard when you have varying opinions on what is dangerous and what is not. It's difficult to separate the effects of multiple hazards and evaluate their risks accurately, especially when exposures are near the threshold of measurement and response. So, in setting standards, here's what we should consider. We should consider the combined effects of exposure, different sensitivities, the effects of chronic as well as acute exposure collectively so that we can determine what level of exposure people are allowed and what kind of protection that they need. It's not reasonable to be protected from every contaminant, no matter how small the risk. Like, we can't just wrap people in bubble wrap and keep them safe from everything. We must consider the effects on other organisms as well and do our best to maintain our environment. All right, ladies and gents, I hope you've learned tons about toxicity, about the fate of these chemicals in the environment, what they can do to people, what they can do to lower life forms. This has been huge and informative. So I hope you got it all down. I'm Mr. Kennedy, and I will see you next time.